Hi, this is Joachim from Elastx. Today's session we are going to talk about disk performance. We are going to do some disk benchmarking on our Easy platform, which is based on Jelastic. And Jelastic is a platform as a service for Java and PHP applications. But during this test, we are going to run it on a virtual dedicated server just for because it's easier that way. This is the Jelastic control panel. Gonna log in there, and I've just created an environment that just includes a single Linux machine. So normally in this type of environment you would use application servers and a database and the build nodes and load balancer and stuff to build your application platform, but in this case we're just going to use a Linux machine because it's easy to run the the benchmarking tools on it. But it's the same infrastructure and the same disk subsystem and everything, so the performance we will get out of the Linux box here is the same performance you would get out of the other database machines and application servers and stuff. Okay, so I have two SSH windows here. One is to the hypervisor and one is on the Linux machine itself. So what we are going to run is two different tools. One is IOZone, which will create a 10 gigabyte file. Can go back and look at the configuration of the virtual machine there, but you see it's 2 gig of RAM and 3.2 gigahertz of CPU power. So the file is a lot larger than the memory in this machine. But the test we are going to run here is pure write tests with IOZone, but still, even if the file is bigger, we will still see a lot of cache hits when we run the read performance tests, and that's not really disk performance, it's just memory performance, and that's not what we are going to try now. So I will kick off this test. There it starts. It starts to write first on a sequential write to build this 10 gig file, and then it will do a random test, that is test number 2 here, on this file. We're using a block size of 4K, and this is the file that we are writing to. In the default environment, like this, we actually have IOPS limits, so it actually limits the machines to only 10,000 IOPS and the throughput of 200 megabytes per second. So when we kick off the test here, we can go to, I have a monitoring system here that actually shows the actual throughputs here. So this throughput is showing you, it actually gives you the ability to burst, so you will actually see more performance than 200 megabytes per second because it actually bursts and then goes down again. And so we see here it's between actually the average performance around 300 to 400 megabytes per second. After this test, it will start to run the random test, write test, and you see the IOPS here. It's about 10K. Because we're limited to 10K, but the same thing here, we actually allows the server to burst, so you will see an average that is a bit above 10K because you have the burst, and then it goes down and slows the traffic down again. So we can look at some IO stat on this device. Let's see here. Here it's the device that is this machine is using. So you can see here that we have around 10,000 IOPS, but it actually burst up to 30,000 sometimes, then it slows down again. But still, well, pretty great performance considering this is a virtual machine in a multi-tenant environment. And the key why we get this kind of performance is that we only run on solid state disk. The whole platform, all the machines that are provisioned in our platform is using solid state drives. So one thing is the number of IOPS per second that you see now. The other thing is of course the throughput, but I would say one of the most important that most people tend to forget is actually the latency that you get against disk. So we're going to use another utility there to actually test the latency. And the latency is when you write a small write to read, how fast you actually get that response. So many systems actually can perform pretty good on number of IOPS and throughputs, but actually performs pretty bad on the latency side. So we're going to look at that. Because that's a single transaction, how fast that actually is, and that's actually the parameter that gives the user the best performance experience when the whole system has very low latency. So you still can see it's running around 10,000 IOPS there. You can go back to the curve there and see that it's it stables out around here and 10,000. Have some peaks because you still can burst a bit, but that's about it. What we are going to do now is actually remove the performance limitation on the system. And let's see here. So we can look at here. You can see that it's limited to 200 megabytes for throughput, and the IOPS limit is 10,000. Okay, so if we're going to remove those limits, just going to set remove limit there, the IOPS limit, and also the IO limit, the throughput limit. So now the system doesn't have any limitation. So this is just to show you the possibility. That's why we can actually guarantee you the performance, because we have quite some margin on it. So a machine without these limitations can actually perform even better. So I'm going to run the same test again here. There you go. And then we can start up the performance test here again. So now we see we have a throughput of over 400 megabytes per second, which is pretty good here. And why we limit this both throughput and IOPS per second is because of it's a multi-tenant environment, and we want to limit it just to make sure we don't get any noisy neighbor problems when user actually takes too much resources to it, so it actually affects the other users in the platform. So remember, this is just a single virtual machine in this platform that performs like this. So I can have multiple machines that actually are performing like this, but still want to limit it, so we will have a good margin on the performance. So here you can see it performs around between 300 and 400 above 400 megabytes per second there for the throughput test. This is actually 4K as well, but as we know, not using any sync flags to opening of files, the operating system actually optimizes the write through. It actually bundles a number of 4K block writes down to disk, so we can get these kind of throughput figures even with 4K blocks. So now it's down to the random test, so there's no bundling there, so now it's real IO going there. So now we see that we have around up to 30,000 IOPS per second, which is I would say pretty good for this kind of environment, multi-tenant and virtual. And we can go back and also look at the performance here, and so you can see it's around here you can see it's around 30,000 per second. Delivering, it goes up and down a bit from, I would say, from 25,000 up to 35,000. I've seen up to 40,000 from a single virtual machine as well. So this is a pretty great number, so I guess. and this test will be finished pretty soon there. And the last test we are going to do on the platform is the latency test. The test is done there, and I'm using a tool here called IOping, which is a nice little tool that you can actually, well, very easy to compile, and then just you can use it on your machine and try it. Here we're going to do some read tests. I'm going to do it on a file that I created yesterday, just to make sure the file is not in cache. So we actually get real read requests down to the storage subsystem. So a normal disk with a normal spinning disk that is not solid state will have a latency around 4 or 5 milliseconds for an enterprise disk or fast disk, if it doesn't have any load on it. And as load gets on, it's easy to get up to 10 milliseconds if it's a medium loaded system, and if it's a heavily loaded system, you will see response times, more latencies, well, up to 30 milliseconds, and then it really will hit performance here. But as we are doing this on a solid state disk, we have a solid response time below 2 milliseconds here, as you can see. So it's closer to 1 millisecond and sometimes below, but each read request is actually pretty fast. As this is reading down to the disk subsystem and reading the actual blocks on the disks. This is quite a lot better than running on traditional spinning disks. And that's why we can actually provide you a predictable performance in the platform, because we don't have these latency issues that is normally the cause of an application that doesn't feel rapid. So I would say that's everything for me. So happy hosting, and I would love you to try this on your environment to see the results, and please compare us and let us know. Okay, great, thanks.